All right, it looks like everyone is here. Good morning, everybody. Oh, that's right, I forgot. You guys, don't talk. Anyways, good to have you here, even if it's just names on a screen. All right, I think I've got everything set up. I realized just this morning that, wait, I haven't actually done a full class as I've been doing from home yet, so I had to make sure my setup matches what I got together at school. So I think everything is working here. You can see my screen. I'm sending the screen to YouTube as well, so we'll have the finished video afterwards, and that's all good to go. So the first thing we are going to do is we're continuing to work on finding limits algebraically. And so I would like for you to go ahead and open up that document. It's the very same one we're going to work on all day today, but let's start by going over the answers for the examples. I guess they were called the examples from last week. So you finished. Here was the first one we did together, number 4. We should have gotten the answer of 6. I think everybody in class then was able to get that. So anybody on their off-color days, go ahead and check your answer there. And then we'll go through to the rest of them. Here is number 5. So as I did before, I went ahead and plugged the number into the function just to verify. Yes, it is 0 over 0 undefined. It doesn't have to be 0 up top in order to be undefined. It's just dividing by 0 that causes it to be undefined. But if you don't get 0 up top, then what you have is probably just an asymptote, not a whole. There would be no removable discontinuity, and you wouldn't be able to do this. Okay? So that's why I always check that first as a hint, like, wait, is this going to be possible? Can I calculate a limit there at all? And so then afterwards, we would factor both the numerator and the denominator. I started with the denominator because the numerator is to the cube power. I can't just 7 rules of factoring that guy. That only works on quadratics. So I had to find a factor that I could synthetic divide the numerator by and hopefully draw it out, right? If neither of these would divide and leave no remainder from the numerator, then I knew, oh, there's actually not a hole here. It doesn't work. Okay? So again, trying to think ahead a little bit as to not only what is the most efficient path forward, but what order of checking things will give me clues as to my potential progress. What will give me stopping points and checks along the way that would flag, hey, wait, this isn't going to work. Okay, so let that be a kind of check on your work there as you go. All right, so I use the simplest one, the factor of x plus 1, so I synthetic divide with a -1 here. And then my result then is 1, 3, -4. That translates back to x squared plus 3x minus 4. And so that's where I had this result here. So this factors into that factor that I pulled out that matches that one. So I know I can eliminate that, and that will be my removable discontinuity. And this is what's left, and I go ahead and factor that portion the old-fashioned way and actually get another x plus 4. So this graph actually has 2 holes in it. Isn't that something? So then when I go back to analyze my limit of the factored forms, I can cross both of those off, and I'm just left with the x minus 1. So for that limit, go ahead and plug the -4 in for x and reduce to -5. All right, now the next one. Have fractions within fractions. So things got a little bit trickier here. If I can get it all on your screen there. So again, check that it is in fact undefined. Yes. And now in order to deal with those fractions, I need to combine these, which means I need to make them have a common denominator. So I'm going to take the denominator of the other one, turn that into a fancy form of 1, and multiply by the other guy. So this one multiplies by 2 over 2. This one multiplies by x plus 2 over x plus 2. And I didn't distribute that denominator. I'm going to leave it in factored form when I can. I just prefer to leave it that way, just in case I'm going to reduce factors later. I'm not quite sure yet where this is going. But that's what I did in previous problems, so I'm going to leave that as a factored form just in case. And then we go to actually analyze the limit, and now we've got a single fraction divided by something else. Fraction divided by fraction, go ahead and multiply by the reciprocal, so I can see clearly that the x's are the ones that reduce, and I just have this left over. So it turns out it doesn't need to be factored. I could have distributed that a while back, and I would get the exact same result, which is going to be, I go ahead and substitute the 0 in for the x into this form, and now I get 1/4. Okay, questions there? No? All right. And let's move on. Last one. Oh my gosh, it's got a radical in it. How are we supposed to do that? There wasn't an example in the actually completed examples with a radical in it. Okay, same process. Check that it is in fact undefined. Check that it's 0 over 0, so I'm probably going to have a removable discontinuity. And then now what do I actually have? What tools are in my algebra toolbox to make this look like something else without actually changing it? As always, you can multiply by fancy form of 1, same thing on top and bottom. But what's actually going to make this simpler, if you recall, would be the conjugate. Anytime you're dealing with a radical or a complex number, both of those bring to mind the idea of conjugates. Take the exact same things, but switch the sign there. Instead of minus, I used plus. Because when I multiply, focus just on the denominator here. When I go to multiply these together, right? Root x times root x is just x. Negative 3 times root x, negative 3 root x, positive 3 root x. So I'm going to get this middle term that cancels out, right? Plus 3 minus 3, that reduces down to 0. Okay? That's why you want to do the conjugate there, to eliminate that middle term and get left with just this x minus 9. And I went ahead and I started distributing these two out and wrote all my terms there. Like, ooh, this is going to get kind of messy. X times square root of x, geez. But then I got here and I saw, oh, wait, this is x minus 9. So before I wrote this out, I saw that this was my result in the denominator. So I went back to here and said, screw that. I'm not distributing that. That doesn't do me any good. I want to eliminate factors. I'm going to leave this in factored form as this times this, because I know one of them is matching. I can see it right there. That's what I'm going to eliminate. So that's what I did. Start to evaluate the limit, eliminate the removable discontinuity. You're left with just limit as x approaches 9 of root x plus 3. Substitute 9 in for x. Resolve. Your answer is 6. All right, how do you like them apples? No questions? You guys are an easy bunch today. Because if you don't have any questions, I've got nothing else for you. Your mission for today is to go ahead and complete this worksheet with the supplemental exercises numbers 1 through 16. Oh my gosh, 16, Mr. Apple, that's a lot. Yes, it is. But you are practicing old techniques, right? Factoring, common denominators, multiplying by conjugates, okay? All of this is old, what should be habits, right? So I hope that in this practice, you're going to get a little quicker with this, start seeing where those pieces can slot in. None of these new exercises bring any new techniques. You don't need any other tools than what we've used so far. Okay, just go in with an open mind. And in fact, oh, look, on the next page, there's all of the answers, so you can check your work as you go. Okay, this is why I don't feel so bad giving you all 16 of them, because you have the answers to check how you're doing. All right? So any questions on that? What are we doing today, or are you all set to go? All right. Thank you for the response, Ruby. I've got one response in chat. Oh, there's two. Okay. All good. All right. Well, then I'm going to leave you to work for the rest of the period on this. Quick shout out to my video that when did that actually post? Yesterday? Right? I'm on the end of the semester stuff. All the information you need is on that video, and full transcript is in the video description if you need to go back and read anything on the details of what's coming up and what we're doing when. Although your class specifically, a little heads up, because you work Tuesday and then you come back for class on Wednesday, please note that that Wednesday class is just a work day scheduled. So you will come to Zoom, report in, or I guess not you guys currently on Zoom, I'm talking more to the other color groups from YouTube here. You'll report in, get checked in for attendance, send me a message in chat of what you plan to work on for the period, and then that's it. Okay? Unless I have something specific I need to discuss with individuals, I'll let you off of Zoom and you can just be free to work at your own pace there. Okay? So that's the plan for Wednesday. So for you guys back here, have at it for today. I'll still be here. You'll still stay in Zoom. Let me know if you do encounter problems with any of these and have questions. I'm happy to help you. But we're going to stop the YouTube one here.